Hey guys, here's a super fast video, I hope, on equations of planes. Okay, so let's make up an equation of a plane. 2x plus y minus 3z minus 1 equals 0. So we call this the scalar equation of a plane. Scalar equation of a plane. And planes are only going to exist in 3 space. So we've got an x, y, z component here, and then this which we call d. So the scalar equation of a plane is written as ax plus by plus cz plus d equals 0. Or sometimes you might see it equal to d. That's a scalar equation of a plane. Okay, so a good skill to have is you should be able to find a billion points on this plane. So say we wanted to find points on this plane. So you just make the equation equal 0. So I'm going to find point A. I'm just going to make this up. So if I choose x to be 1, I know I got 2 times 1 plus, I'm just going to pick a random value for y. I'm going to pick negative 1. So 2 times 1 plus negative 1. And then I have to find something that I can sub in for z that will, when I subtract 1, make my equation equal 0. So let's say I just made it 0. Hopefully that works. So 2 minus 1 minus nothing minus 1 will equal 0. Okay, so since that works, I'll put 0 for my z coordinate. Okay, so I know that point's on the plane. So you can make up any points you want on the plane. So I'm just going to make up 2 more. Whoops, what was that, 2? Okay, so for B, I'm going to pick 0, 4, 1. 0, 4, 1, yeah, I think that works. And 2, 0, 1. So you can make up any points on the plane. And that's how you do it. You just randomly pick stuff and make the equations left side equal the right side. Okay, so you have to know how to do that on a plane, find points on the plane. And then if you had to create a vector that lies on the plane, to do that you could use your points that are on the plane. So like let's say this is our plane and we know these 3 points. If we wanted to create a vector that was lying on the plane, then we could just find the vector between 2 points. So that could be like vector AB, for example. Okay, so to do that, we just subtract our points. So say we wanted to find vector AB. So vector AB would be, if we just took B, subtract A. So that'd be negative 1, 5, 1. Thanks. And then if we wanted to find another vector, we could do BC or BA. Like there's a bunch of possibilities. Okay, so those would be my 2 vectors on my plane. So now I've found 3 points on my plane, 2 vectors on my plane. So now I can write a vector equation of my plane. So to write a vector equation of a plane, you need to know a point and 2 direction vectors. So the vector equation of a plane looks like this. There's my point, and then these are my 2 direction vectors. So these are my 2 direction vectors, and this is my point. So I'm just going to sub all that in so I have a vector equation of a plane. So I can pick any point, A, B, or C. I'm just going to pick C because that's all I can see right now. So 2, 0, 1, and then I got my 2 direction vectors, A, B, and BC. So negative 1, 5, 1, and 2, negative 4, 0. Okay, so that's a vector equation, and then the rest of the stuff is exactly the same as a line. So if you wanted to make a parametric equation, just isolate your x, y, and z components. So x would equal 2 minus t plus 2s. Y would equal 0 plus 5t minus 4s, and z would equal 1 plus t minus 0s, so 1 plus t. So those are my parametric equations. Okay, awesome. So now I have a scalar equation, a vector equation, and a parametric equation. All of those things I need to know for planes. Let's say we didn't have our scalar equation. So if we just knew our vector equation and our parametric equations, in order to get from there to create a scalar equation, we proved this thing in class, which was we proved that A, B, and C, so A, B, and C, so if we created a vector A, B, and C, it turns out that this vector, A, B, C, is actually perpendicular to our plane. So we call it a normal vector, and it's perpendicular to the plane. So in order to create a scalar equation of a plane, you need to find a vector that's perpendicular to the plane, and then you'll know your A, B, and C coefficients. So you should know from C2 to create a vector that's perpendicular to two other vectors. So if we have these two vectors and we want to create a vector that's perpendicular to those, we have to use cross product. So cross product will create a vector that's perpendicular to that and perpendicular to that one. So you actually need to take the cross product of two vectors that are on our plane. So we can use our two direction vectors, take the cross product of those, and that'll give us the scalar equation of our plane. So let's quickly do cross product. So I hat, j hat, k hat. I hat, j hat, k hat. Shh, I'm running out of time. Okay, -1, 5, 1, -1, 5, 1, 2, -4, 0. Sorry, 4, 0, 2, -4, 0. Okay, so if I do my cross product, I'm going to do 0 minus -4, so that's 4. Sorry if I mess this up, I'm trying to do it fast. 1 times 2 is 2. So 2 minus -1 is 3. -1 times -4 is 4. Minus 10, so -6. Ooh, I hope I didn't mess that up. Actually, I can find out soon. So that would be our cross product. Ooh, that doesn't look good. Does it? No. Does not. Did I mess that up? Okay, let's check. -1, 5, 1, -1, 5, 1, 2, -4, 0, 2, -4, 0. Okay, let me just double check here. 0 minus -4 is 4. Okay. Then we got 2 minus, 2 minus 0. I messed that up. That should be 2. 2 minus nothing, is 2. Then 4 minus 10 is -6. Okay, awesome. That's our cross product. And then remember I said it's kind of like reducing it to lowest terms, kind of. So you want to reduce that vector to its smallest thing. So right now it's like a scalar multiple. So I'm going to divide everything by 2. So my vector will turn out to be 2, 1, -3. So that's just from doing the cross product. So now I know that's A, B, and C for my scalar equation. So like 2x plus 1y minus 3z plus d equals 0. And let's just scroll up. 2, 1, -3. 2, 1, -3. Sweet. So we got that. And then in order to find out what d would equal, you're just going to sub in a point that's on the line for x, y, and z, and then solve the equation. So like a point on the line could be 2, 0, 1. We have like 3 points on our line here that we know. You can sub in any of them. So I'm going to use 2, 1, 0. So I'm just going to sub in 2, 1, 0, and solve for d. So I get 4 plus 1 plus d equals 0. So d will equal -5. Does it? No, I can't do math. What the heck? Did I sub that in wrong? It's 2, 0, 1. Ha! I'm trying to go fast. I'm going slow. 2, 0, 1. Sorry about that. So I got 4 minus 3 plus d equals 0. So d is actually equal to -1. Amazing. 2x plus y minus 3z minus 1 equals 0. Scalar equation of a plane. Boom. Done. The end of the video.